Hi, everybody. My name is Oscar Elizondo.
I'm Lawrence Harrington.
And my name is Rachel Sosa. And today we're going to be interpreting graphs of derivatives. So the references that we use for this cosplaying were Khan Academy, the textbook, the learning modules on Quest, and some YouTube videos. Okay, so a fun fact that we actually learned in class is that if a function gives you the position of something as a function of time, the first derivative gives you its velocity and the second derivative gives you its acceleration. Okay, so for this cosplaying, we're being presented with the problem, and it says that the revenue for a manufacturer, it's R of X, $1,000, where X is the number of units of goods produced and sold, and R of X and R prime of X are the functions given below. So just by looking at the graphs, we can see that graph B represents the derivative of graph A. So that's the conclusion we can come up to. Oh, what does it look like that? Oh my God. Oh, you just, okay, never mind. Okay, so for this question, which is being asked, what is the revenue from producing 40 units of goods? And this one, you can just look at the graph and tell that X equals 40, the Y value will be 75. So our final answer would be that when 40 units of goods are produced, the total revenue will be $75,000. You muted.
For my problem, it asked what is the rate of change in revenue called the marginal revenue when 17.5 units of goods are produced. For the rate of change, because the position on the graph or X value, the derivative of that is always going to be our rate of change. We just have to look at the derivative graph, which look at the same value, which is 17.5. And at 17.5, the graph is at 3.2. So our rate of change 17.5 is going to be 3.2. For the next problem, it asks at what level of production is revenue 45,000. We look at 45,000 on the y-axis, and when the production is at $45,000, we are making 50, or the company itself is making 15 units.
For one of the last questions, it says, at what levels of production is the marginal revenue $800? And interpret what it means in terms of revenue producing an additional item. So we had to look at the derivative of the graph where it was fluctuating down. And we could see at point A, since it was in the thousands, 0.8 would be $800. And down in the negative, 0.8 would be $800 as well. So in the derivative function, we can see that our revenue value plummets to the hundreds range. And we can see that our number of production with $800 is approximately 32.5 amounts of production. And then while falling into the negative values at negative 800, we can see that it falls into 37.5 amounts of production. And the relationship between these is that saying adding an additional product can cause a requirement of more money being put into that product and more production being caused. So the more money you're putting in the production of that product, is the lower your revenue would be and the more product you will have. And for the last question, it says, at what level of production is the revenue greatest? What is the marginal revenue at this production level? And explain why this relationship between the answers. So at the highest or the greatest marginal revenue, you can see this at 36.6 approximately, because we don't have the exact value. Well, it is bad, but we can't necessarily say just looking at the graph we'd have numbers, but it's at the very highest point on the graph, so that would be the highest revenue for that. And so the highest revenue would be 79,000, because at the top of the graph, that's where 36.6 matches up. And the correlation of the 2 points is the graph at 36.6, and we match it with revenue. And that's is our presentation on interpreting graph the derivatives. If y'all have any questions, y'all can let us know.